In algebra, when we get to more advanced equations, sometimes we will find problems in which there are variables on both sides. For example, you can see that I have 5x on this side, and I've got negative 2x on this side. I've written this equation 2 times because if you are reading what I've written here in pink, there are always 2 options for our first step. And one choice will give us a positive coefficient. And you guys remember how lazy I am. And to be honest, I don't really like working with negative numbers. So I'm always going to try and have a positive coefficient when I'm solving an equation. So here's what I mean by saying that there's 2 options for my first step, and the reason that I've drawn this equation twice. I'm going to go ahead and put in a balance line onto both of my equations. And I'm going to look at the variables. Remember, I usually ask you to circle the variable. In this case, the variable is x. And on one side, I've got 5x, and on the other side, I've got negative 2x. And I want to move the variables to one side using addition or subtraction. That's my goal that you see right here. So if I wanted to move this 5x, what I'm going to need to do is to subtract 5x from both sides. Remember, the balance line tells me what I do to one side, I've got to do to the other. And just like we've been doing in all of our other equation solving, if I had 5x's and I took away 5x's, this becomes 0. This is a 0 pair. And on the other side, I can combine these like terms. Negative 2x take away 5x is negative 7x. I'll bring down the rest of the equation. Do I really need that plus there? No, I don't, so I'm going to erase it. And I'll bring down that 33. So that was one way I could start this problem. I started this problem by subtracting 5x from both sides. Let's go ahead and see what the other option would be. I again circled my variables with their coefficients, and instead of starting here and subtracting 5x from both sides, I'm going to start here. How would I get rid of minus 2x, or what is the inverse of minus 2x? Well, the inverse is plus 2x. And my balance line is there to remind me what I do to one side, I must do to the other. And just like in those other problems, I am going to show that a plus 2x and a minus 2x is 0. They're a 0 pair. They've canceled each other out. And what's left over here, 5x plus 2x, is 7x plus 3 equals 33. Now, if I have to choose between these 2 equations that are now written here in red, it doesn't matter which one I choose. I will get the correct answer either way. But because I would rather work with positives than negatives, I would rather work with a 7x than a negative 7x. So I'm going to start this problem by solving this one that has a positive coefficient. So I circle my variable with its coefficient. I ask myself, how do I get rid of plus 3? The answer is minus 3. Subtract 3 from both sides, this becomes a 0 pair, and I'm left with 7x equals 30. My final step will be to divide both sides by 7. Why do I divide both sides by 7? Because 7 divided by 7 is 1. Now, you guys know I don't write 1x, I just write x. But I could leave my answer 30 over 7, or I could go one step further, just like you did on your do-nows at the beginning of this year. 7 goes into 30 4 times. 7 times 4 is 28, which means I've got 2 left. My answer is 4 and 2/7. Let's go ahead and look at what would have happened if I would have solved the other equation. I want to prove that there isn't a right way or a wrong way. There's just maybe a little bit easier way. So I'm going to start by circling my variable with its coefficient. Negative 7 is the coefficient. And I have to get rid of this plus 33. I get rid of plus 33 by doing minus 33 because that is the additive inverse. It is the opposite. And I'm going to show that that becomes 0. It's a 0 pair. And what I have left is negative 7x on the right-hand side. And on the left-hand side, I look, are those same signs are different? They're different. So I subtract. 33 take away 3 is 30, and it is negative. Now my final step is to get the x by itself. I know that there's multiplication hiding here, even though I don't see it. And the opposite of times by negative 7 is divide by negative 7. And what I do to one side, I must do to the other. The reason I chose negative 7 is because 7 over 7 is 1, and the two negatives make a positive. So I'll just write 1x, written that way without showing the number 1. And on the other side, I see two negatives, which gives me a positive answer, and 7 goes into 30 4 times. 7 times 4 is 28, and I've got 2 left over. Now I can see that I got the exact same answer, but the reason that I prefer to work with positives over negatives is because a lot of times on problems like this, students will forget to divide by a negative. And then you would end up with an answer with the wrong sign. So in order to try and fix that, I'm just going to choose to use the side with the positive coefficient. So let's look at another problem. I'm going to go ahead and put a balance line in on both of these problems. As you can see, the equation is the same. I've just written it twice because I always have two options to start, and one option will give me a positive coefficient. So I could start by adding 10x to both sides. That would make this a 0 pair. The other option, which I'll show on this other side, is to add 4x to both sides, because that would make this a 0 pair. Either one is an acceptable first step, but one of these ways will give me a positive coefficient to work with. What happens when I've got a positive 10 and a negative 4? Different signs, so we subtract. 10 take away 4 is 6x, and it is a positive because the 10 is bigger. Let's take a look at this other option. I've got a negative 10 and a positive 4. Different signs, so we subtract. 10 take away 4 is 6, and this time it will be negative because the 10 is bigger. So here are the two equations I can work with. The one written in blue, negative 6x plus 8 equals negative 58. Or on this other side, 8 equals 6x minus 58. Hopefully you're starting to see a pattern now, and maybe you can start figuring out in your head which is the better first step. I now have two equations. They're both correct. I can solve either one, but I probably want to solve the one with a positive coefficient. That would be this one. I begin by circling the variable. How would I get rid of a minus 58? That would be a plus 58. My balance line reminds me what I do on one side, I do to the other. And I'd like you to finish that problem. Sometimes you might have to distribute or combine like terms. Sometimes you might have to distribute and combine like terms before you start. So I want to look at an example of what this looks like. I can tell this is the distribution right here, the negative 8 right next to this set of parentheses. I'm going to go ahead and put in my balance line. And I begin by saying negative 8 times 10 is negative 80, and negative 8 times positive x, negative 8x. Now I haven't changed anything on this first side, so I'm just going to bring it down. Remember, this is why we fold our paper in half, so that we are working vertically. You can see my steps. They line up one right after the other. And now I have a choice. my choice is I can add 9x to both sides. That would make this side a 0 pair, and that would make this side a positive 1x. That's one way to start the problem. The other way to start the problem would be to get rid of that negative 8x over on the other side, and that would be to add 8x. What I do on one side, I do to the other. And this will be 0, because it's a 0 pair. And on this side, 9 take away 8 is 1x, and this time it's negative because the 9 is bigger. So after doing that, I can see that what I actually wanted to do was what I did in the first place. The better first step, because I want to work with positive numbers, was to do that minus 9x. So I'm going to go ahead and put this the way that it was with the plus 9x on both sides and showing that that makes a 0 pair here. And this will leave me a positive x. And again, I'm working vertically, so I can just bring straight down this negative 80, my equals sign, and all that's left on this side is a 14. And now I have a pretty easy problem to solve, a problem that you guys are all experts at this point at solving. There are two special kinds of problems, and the first one is called equations with no solution. So it looks like I need to distribute here first. I'll put in my balance line, and I'm going to do 10x. 5 times 1 is 5. I've got the variables on both sides. I need to try and move them to one side. I would have to subtract 10x here. What I do on one side I do to the other, so I'll have to subtract 10x here. This is a 0 pair, and I'm going to look at the other side, and that's a 0 pair also. This is kind of weird. Okay, I'm going to bring this straight down. 5 equals, well, what's left over on this other side? Nothing, it's a 0. So when I finish this equation, I have 5 equals 0. And how often is this true? How often is 5 the same thing as 0? Never. Okay, that's never true. So I'm actually going to put the little line slash through the equal sign so that I can see that that's not true. And if this was a question on your homework that you were trying to find the solution, you would actually write the words no solution. There is no number on the face of the planet that can possibly make this equation true. Nothing will make this equation true. The other special case is equations where all real numbers are true. And I can see again here that I need to distribute. After I put my balance line in, I get 6x plus 2. I'll bring down this other side. Hasn't changed. Just write it right beneath. And now I need to move all the variables to one side. Well, I would have to subtract 6x to get rid of that, make it a 0 pair. If I subtract 6x on this side, I have to subtract 6x on this side, and actually that's also a 0 pair. So now my equation looks like this. 2 equals 2. That's kind of weird also. So I need to ask myself, how often is this true? How often is 2 the same thing as 2? Well, that's always true. This is always true. And if you had a solution like this on your homework, and instead of just saying x is 5 or x is negative 7, you would have to say that all real numbers are solutions. That means I could plug in any number up here at the top. I can plug in any number for x, doesn't matter what it is, and it's going to work. The problem will work.